Hello everyone. Today we're going to talk about the geometric distribution. Now, before you think this is something completely new, we've actually already used it in our previous lesson on the negative binomial distribution. So, remember when we solved the problem about finding the expected number of townspeople to approach before meeting the first blacksmith? So that was the geometric distribution. We just didn't call it that at the time. So what exactly is geometric distribution? It's actually just a negative binomial distribution in its simplest form. While negative binomial asks how many trials for our success, geometric specifically asks how many trials for that first success, meaning R is set to 1. So I'm giving you an example to show the difference between negative binomial and geometric. For negative binomial question, keep flipping a coin until you get 5 heads. How many flips will that take? So here we're waiting for multiple success until we manage to get 5 heads. R equals to 5. For geometric question, keep flipping a coin until you get your first head. How many flips will that take? With this, it asks for only one success, so only one head, which is R equals to 1. So the key point here is whenever you hear the first success or until one success occurs, that is the geometric distribution, which is just negative binomial with R equals to 1. Let's look at the specific formula for geometric distribution and see how it connects back to what we already learned. We see geometric random variable can be written as this from negative binomial, but with R already set to 1. Remember that geometric is the special case for negative binomial distribution where we're only looking for one success, or you can write GOP since R is always 1 anyways. So X represents the number of X of repeated trials to get one success. P is the probability of success or failure. And here on negative binomial, 1 represents the probability of first success or failure. So not too hard to understand, yeah? Now, the probability function. So you see here, this represents all the failures that happen before the final success. So for example, if we succeed on the trial X, that means we fail on the previous X minus 1 trials. Since each failure has probability 1 minus P, we multiply it 1 minus 1, X minus 1 times. So notice X can be like 1, 2, and 3 and so on. The minimum is 1 because you could succeed on your very first trial, and P must be between 0 and 1 as with any probability. Finally, the mean and variance. All this formula we have learned here are much simpler than the general negative binomial formula because we simplify it to the case where R is equals to 1. Now, let's try apply what we have learned. This topic is very short and quite easy when you already know how to use the negative binomial. So starting with exercise 1, at a cafe near the station, the probability that an office worker stops by for coffee on any given morning is 0.18. We start with A, find the probability that an office worker visits for the first time on the 7th morning. So we're given the probability they visit the cafe on any morning is 0.18. This is our p-value. Look at the keyword here. First time on the 7th morning. First time, first. So we use geometric formula since this is the geometric distribution problem because we're looking for the first success. So let's plug in the x value. So x equals to 7, p equals to 0.18. The final answer is 0.05472 or about 5.47%. If you want it in percentage or if the question asks for it. So there's roughly a 5.5% chance that the first researcher visit happens exactly on the 7th morning. So part B, find the expected number of mornings before he or she visits for the first time. So here the word expected means it's asking for the average or mean. We have covered this before during the previous topics on the negative binomial. This time we now know we're applying geometric. So yeah, just use mean formula for geometric. We already know P is 0.18. Final answer is 5.56. This means on average, we observe this cafe many times. We expect to wait about 5 to 6 mornings before seeing the first office worker visit. So that's all. Usually I would give at least 2 exercises, but there's nothing complicated about geometric. I mean, it's just an extension of negative binomial, but it has a proper name, so I feel like I should cover it regardless. Anyways, thanks for watching and I hope this proved to be useful on your studies.